Hello everyone, I am Arokkia Saibbe from KPR College of Engineering and Technology, Coimbatore. Today we are going to learn about Introduction to Stochastic Processes and its classification. So before moving on to the stochastic processes, we should know what is probability. Probability is a measure that helps to find the chance for the occurrence of any event. In probability, the samples are gathered in such a way that the entire population has equal chances of being selected. And in probability, a countable number of random variables are considered. And in stochastic processes, we will be considering a sequence of random variables. So here the definition is, stochastic process is nothing but a study about a sequence of random variables that varies with respect to the time. So in this video, we are going to learn about introduction of stochastic process with few examples and its classification in one dimension and also the examples in those types. Here is the definition of stochastic process. A family of random variables xt where t belongs to the set T. This xt is nothing but a stochastic process and the set T is either discrete or continuous. So now let us go on to the topic called state space. A state space is nothing but a set of all possible values of a sequence of random variables of xn, where this state space is either discrete or continuous. Now let us have one example that explains what is stochastic process, state space and index set. So here is the example. So the stochastic process here is xn that defines outcome of throwing a die for the nth time. So here the index set is, suppose if I throw a die for the first time, second time or third time, suppose if I continues for the nth time, the outcome will be takes 1, 2, 3, 4, 5, 6. So this set is nothing but state space. Whereas the index set is nothing but for each n, the outcome varies. So this n takes the value 1, 2, 3, 4, etc. So this taking values is nothing but the index set. So this is nothing but the definition example of stochastic process. Now let us have another example in multi-dimension. So here let us take a stochastic process xn is nothing but yn, zn. This stochastic process represents the scores of two students in their nth subject. So yn represents the score of the first student in his nth subject and zn represents the score of the second student in his nth subject. Let us take the value for n is 1. If my n is 1, which means x1 equal to y1, z1, which means y1 is nothing but score of the first student in his first subject. Z1 is nothing but score of the second student in his first subject. Suppose let us take n is 3. Then this y3 is nothing but score of the first student in his third subject. And Z3 is nothing but score of the second student in his third subject. So here the index set is nothing but the finite number of subjects. So here the index set is discrete and finite. The state space is nothing but the values taken by this stochastic process. So here the values are nothing but the marks scored by the students. So the state space takes the values from 0 to 100. Now let us have the classification of stochastic processes in one dimension. These types are considered with respect to the time as well as the state space. So based on the time and state space, here are the four types, that is discrete time, discrete state space, discrete time, continuous state space, continuous time, discrete state space, continuous time and continuous state space. Now let us have an example for these four types. The first type is have discrete time with discrete state space. So here the stochastic process is number of calls received by the person on the nth day. So this stochastic process is nothing but denoting the number of calls received by the person on the nth day. So the index set is nothing but 1, 2, 3, etc. where the state space takes the value from 0, 1, 2, 3. Now let us have a doubt why the 0 comes. This 0 is nothing but that person might receive 0 calls in the nth day on any day. So for that case 0 is considered in the state space. I hope now you got the point. Now next type is continuous time and discrete state space. So here the stochastic process is the number of calls received at the switchboard during the interval 0, t units of time. So here this stochastic process is denoting the number of calls received at the switchboard within the interval of 0, t. So here the index set is nothing but the interval 0, t where the state space takes the values from 0, 1, 2, 3. I hope you know how this 0 comes. This 0 represents 0 number of calls received at the given time. So it may comes. So the state space takes the values from 0, 1, 2, 3, etc. Next type is continuous time with continuous state space. So in this type, the example is temperature of a particular place in the interval 0, t units. So here the stochastic process denotes the temperature of a particular place in a fixed interval of t units. Here the set of all possible values for the state space is also continuous, as well as the index set also takes the values in the continuous form, which means the temperature of the particular place lies in the interval of 0, let us have some 50 degree or something. So this temperature is also continuous, whereas the state in the index set is also continuous of the interval 0, t. And this is the last type. Here the type is discrete time with the continuous state space. Now let us have an example. Time taken for the nth replacement of a computer in a lab. So the stochastic process which is mentioned in this problem is xn, that denotes the time required to replace the computer in a lab. So here the replacement of the nth computer is considered as index set. So here the index set takes the values from 1, 2, 3, etc. Whereas the state space of the stochastic process lies in the interval 0 to infinity. So this example represents that the time taken to replace the first system is nothing but the state space. So that value lies in the continuous form. Whereas the replacing of the first computer, replacing of the second computer means that index set takes the values from 1, 2, 3, etc. So this is the example. So far we have learned 4 types that changes with respect to time and state space. So here are the 4 types. I hope you all understood those 4 types with the given example. And I hope you all like this video and subscribe for more videos. Thank you so much, and we'll meet you in the next video. Bye-bye. Take care.